Check this out. We've got something really fun today. This is so amazing. Oh man, again?
Review. Take the natural log of both sides and simplify. So the natural log of y and the natural log of 5 to the power of x times cos x times the square root of x. There's nothing to simplify on the left side, but using our log laws we can break this apart, and maybe that's simpler. We'll say the natural log of 5 to the power of x, and we can take that x in the exponent position and drop it in front to be x natural log 5, and then plus, because we're multiplying inside here, the natural log of cos x plus, and we can do the same thing with this. We can rewrite the square root of x as x to the power of 1/2 and then drop it in front, so 1/2 natural log of x. Now we want to differentiate this equation here, and it's got 4 terms, so we'll use the product rule here. So the derivative of 5 to the power of x is just 5 to the power of x times the natural log of the base, which is 5. And then times the other 3 terms, don't change them, just rewrite them here. Plus, now the natural log of 5 is a constant, so we don't need to take the derivative of that and write it here. We'll just move on to the next one. So 5 to the power of x times the natural log of 5 times, we need to do the derivative of this, so e to the power of 2x minus 1 times the derivative of 2x minus 1, which is just 2, and then times the last term sine x, unchanged, plus, and we'll leave the first 3 terms unchanged, and we'll take the derivative of sine x, which is cos x. And then we can probably factor something out to try to simplify this. So every term in here has a 5 to the power of x, so let's factor that out. 5 to the power of x times every term has a natural log 5, every term has an e to the power of 2x minus 1, and just to keep the pattern going, I'm going to factor out a sine x as well. And what's left after we factor out all of that from this first term is just the natural log of 5 plus this one here just has the 2 plus this one here is cos, and we would have to divide by sine, so that would be cotan x. 8.6 Logarithmic Differentiation. We want to find the derivative of y equals x to the power of x. Now you might be tempted to try to use the power rule here, but the power rule only works when we have a number up here in the power position or the exponent position, and we've got x. You might also be tempted to use the exponent rule since x is up here, but that requires the base be a number or a constant. So neither of those rules will work in this case. So we need to think about what other tools do we have that will get x out of the exponent position. And that would be using logs. So here's the steps to logarithmic differentiation. Take the natural log of both sides, then use implicit differentiation, and then solve for y prime. So we'll take the natural log of both sides, and then we can take this x out of the exponent position and make it x times the natural log of x. And now we can take the derivative of this. So the derivative of the natural log is 1 over its argument times the derivative of its argument. And on this side we need the product rule, so the derivative of x is just 1 and then plus, leave x alone, the derivative of the natural log of x is 1 over x. So that gives us y prime equals the natural log of x plus 1. And we're going to multiply both sides by y so that we can solve by y prime. And we don't really want a y here normally, so we're going to use the original equation to get rid of that y. So y prime equals the natural log of x plus 1 times x to the power of x. And that would be the derivative. And just for interest's sake, this is how x to the power of x would look. Find the derivative of y equals 2 to the power of x times the square root of x using logarithmic differentiation. So first we'll take the natural log of both sides, and then we will simplify using our log laws. So we can split it up, and we can also drop the exponents down. So this would be x times the natural log of 2 plus 1/2 the natural log of x. And now we're ready to take the derivative. So the derivative on this side is always 1 over y times y prime. The derivative of this is just the natural log of 2. And the derivative of this is 1 over 2x. And multiply by y on both sides. So y prime is equal to the natural log of 2 plus 1 over 2x times the original. So this thing here, 2x times the square root of x. Now there's nothing inherently difficult about this question. We could have done this one before. We don't need logarithmic differentiation. So we're just going to use our normal rules and check to make sure that we get the same answer. So y prime is equal to, we'll just use the product rule here overall. And first the derivative of this first term, we'll need the exponent rule. So that would be 2 to the power of x times the natural log of the base times this term here, plus, leave the first term alone, 2 to the power of x. The derivative of this is 1 over 2 square root of x. And then if we actually factor out a 2 to the power of x and the square root of x, then we end up with the same thing here. We could do this question using the quotient rule, but that doesn't look too nice. So let's try logarithmic differentiation. So we'll take the natural log of both sides, and then using our log laws, we will break up this quotient here. So just rewrite this one more time. Before we take the derivative, we've got the natural log of e to the power of x, and that's just x, plus, how about the 1/2 natural log of x squared plus 1. So the 1/2 comes from rewriting this square root into an exponent of 1/2 and then dropping it in front of the natural log. And then we're dividing, so that would be minus. The 3 will drop in front, the natural log of x. Now we're ready to take the derivative, and you can see this will be a much easier derivative than trying to do the quotient rule with this. So we'll do 1 over y times y prime equals derivative of x is 1 plus. The derivative of this is just 1 over 2. 1 over x squared plus 1 times the derivative of x squared plus 1, which is 2x. So this 2 and this 2 will cancel. Then we've got minus 3. The derivative of natural log of x is 1 over x. Let's rewrite it like that. Now we need to multiply both sides by y. So we get y prime is equal to, we'll put all these ones in brackets, 1 plus x over x squared plus 1 minus 3 over x, and then times y, which is our original, that would be this thing here, times e to the power of x square root of x squared plus 1 over x cubed. Once students see how simple logarithmic differentiation can be in some instances, they want to use it every time. But please don't use it every time. Some questions it makes it more difficult, and some questions it makes it easier. You only want to use it if it makes the question easier. This question, it does not make easier. We know that y prime is just 2x. We could use logarithmic differentiation, take the natural log of both sides, drop the 2 down in front, take the derivative implicitly, 1 over y, y prime, 2 over x, y prime is equal to 2 over x times y, and sub out the y here with x squared, and cancel one of the x's out to get 2x. See? 1 line, 6 lines. Don't use it every time. Let's go back to the review question 1b and try it with logarithmic differentiation. So we'll take the natural log of both sides, and on this side I'm going to use our log laws to break it up, and also use our log laws to drop the exponent down as coefficients. So the first one would be x natural log of 5 plus the natural log of the natural log of 5 plus 2x minus 1 plus the natural log of sine x. Now we'll take the derivative implicitly, so 1 over f of x times f prime is equal to the natural log of 5. This is a constant, so it would just be 0. This is plus 2, and this is 1 over sine. Let's do this one, 1 over sine, and then the derivative of sine is cos. And now we're going to multiply it by the original function. So we got f prime is equal to natural log of 5 plus 2 plus, we can rewrite this as cotan x times the original, which is 5x times the natural log of 5 times e to the 2x minus 1 times sine x. And when we compare that and what we originally did, we see that they are the same. You should be able to use logarithmic differentiation. Here's some questions from the textbook. Give them a try, see if you know what you're doing.